In the previous section, we introduced addition and subtraction formulas for trig functions. We'll now look at another class of formulas, and these are going to be special cases of the addition formulas. This special class of formulas are called the double angle formulas, and we'll begin by summarizing what these are. We'll have three cases again, one for sine, one for cosine, and one for tan. Sine of 2 theta is equal to the following. Cosine of 2 theta has three different variations, and they're going to be the following. And finally, tan of 2 theta is going to be equal to the following. We'll look at a proof of only one of these, because a proof will work for each of these cases. And the basic idea is to start with our addition formula, and then set the two arguments equal to each other and simplify. For example, let's look at sine of 2 theta. Sine of 2 theta can be rewritten as a sum. This is going to be sine of theta plus theta. Then, applying our addition formula, we'll get that this is equal to the following, which simplifies to be 2 sine theta cosine theta. And so we're done. Let's go ahead and look at a few different examples using the double angle formula. So we'll begin with a warm-up, and what we want to do is we want to simplify cosine squared evaluated at 32 degrees minus sine squared at 32 degrees. The first thing to notice is that we have a relationship that cosine squared theta minus sine squared theta is going to be equal to cosine 2 theta. This means we can apply this identity to the evaluation up top, and we'll get that this is going to be equal to cosine of 2 times 32 degrees, which is equal to cosine of 64 degrees. And this would be our final answer. Let's go ahead and look at another problem. And we want to evaluate sine of 2 theta, where we're given sine of theta, and we also know that theta is in the second quadrant. So initially, what we can do is we can construct our right triangle with this information that's determined by this sine theta and this theta here. The first thing that we know is that this triangle is going to live in the second quadrant, and it's going to have an opposite side length of 1, and it's going to have a hypotenuse of 7, and the angle is given by theta here. Now let's go ahead and find the remaining unknown side using the Pythagorean theorem. So we'll get 7 squared is equal to a 1 squared plus, we'll call this side x, and x squared. Solving for x, we'll get that x is equal to the square root of 48. Now, the only thing that we need to realize is that this x is going to be negative, so this is going to be the negative square root of 48, since our x is in the negative direction. Now, apply the double angle formula to sine of 2 theta, and we'll get the following. And now we just need to go ahead and evaluate the right-hand side of this equation at sine of theta and cosine of theta. So we're already given our sine of theta. This is going to be 2 times 1 divided by 7, and we already found what our cosine theta is going to be since we have our right triangle. This is going to be given by a negative square root of 48 divided by 7. And we simplify this to be a 2 with a negative in front times the square root of 48 divided by 49. Let's look at a verification problem. And we want to show that tan of 2 theta is equal to 2 divided by cotan minus tan. Apply the double angle formula to tan of 2 theta, and we'll get that this is equal to the following. Now multiply the top by 1 over tan theta, and multiply the bottom by 1 over tan theta. Multiplying this out, we'll get up top just 2, and then on the bottom we'll have a 1 divided by tan theta minus tan theta. Since 1 divided by tan theta is equal to cotan, we finally get the right-hand side of our original equation, which is going to be 2 divided by cotan theta minus tan theta. Let's look at one more problem, and what we want to do is we want to simplify cosine of 3x in terms of cosine x. First, let's go ahead and rewrite our cosine of 3x. And we can write this as a product, so this is going to be cosine of 2x plus x. Then we can apply our sum formula, and we're going to get that this is equal to cosine of 2x times cosine of x minus a sine of 2x times sine x. Now apply the double angle formula to these two trig functions, and we'll get that this is equal to the following. We'll get a 2 cosine squared x minus 1 times our cosine x minus a 2 sine x cosine x times sine x. Multiply this out and add like terms in this part, and we'll get that this is equal to a 2 cosine cubed x minus our cosine x minus a 2 sine squared x cosine x. Now we can replace our sine squared x with a 1 minus cosine squared x, and we'll get that this is 2 cosine cubed x minus cosine x minus 2 times our 1 minus cosine squared x times cosine x. And again, multiplying out what we have, we'll get that this is equal to a 2 cosine cubed x minus cosine x minus 2 times a cosine x plus 2 cosine cubed x. So simplifying this last piece over here, we'll get that our cosine 3x is going to be equal to a 4 cosine cubed x minus 3 cosine x.